All right, I'm back. This is the first model that we're going to be doing. Find any value or values of C for which the mean value theorem guarantees on the a to b interval -2 to 1 for f of x equals xq minus x minus 1. Definitely the first thing that you would want to do is pick up your calculator and verify that f of x is differentiable on -2 to 1. So that would require you to change up your window a little bit. You will see that it is a polynomial function and that it is completely continuous between -2 and 1, and that there's no cusps or corners on that graph either. So again, I can't emphasize that enough, that the mean value theorem can only be applied if you do have a differentiable function that you're working with in that given domain. And we do. So we're going to proceed with the formula that we derived earlier. So this is going to take just a little calculations really on the side. So the first thing I'm going to work on is identifying the slope of the secant line over -2 to 1. So I'm going to find my f of -2 as well as my f of 1 on the side here. So we are subbing them into the original function. And I will do the same for 1. Let's see here. So this is going to be -8 plus 2, which is -6, minus 1 looks like -7. Uh, 1 minus 1 is 0, minus 1 looks like that would be -1. So we just established that we're really working with the formal endpoints, -2, -7, and 1, -1. So if we were to find the slope of this line, we would do -7 minus -1 all over -2 minus 1. So it looks like that slope is going to work out pretty well. That's going to be -6 over -3, which gives us a nice +2 slope. All right. So we basically set ourselves up for the left side of the formula. So now what we're going to do is we're going to work on coming up with the right side of the formula so that we can set it equal to 2. So that's going to require us to find the derivative of f of x, which is pretty simple to do. It's just a couple of power rules, or a few power rules that we have to do. So f prime of x is going to be 3x squared minus 1. Now really what you're supposed to do is you're supposed to replace the x with c and say that it's 3c squared minus 1. So based on our formula, we know that these findings should be equal to each other. So we know that 2 should equal 3c squared minus 1. So we're going to go ahead and make an equation now and set them equal to each other. And we're simply going to solve. So I see that I'm just going to add the 1 over and divide out by 3. And we're going to square root both sides. And you have to really remember, in a situation like this, you're square rooting each side of an equation, that the solution is positive or negative. And now is the time that you have to be careful. So if you go back to your our diagram here, it says that the mean value theorem says that the c value will be in between the given domain of a to b. We have 2 c values that we have to analyze here. We have c equals 1 and c equals -1. And it's certainly possible to have more than one answer. However, you have to make sure that your c values are in between the given a and b values. And we do not have that situation over here. C is equal to 1, and that is not in between -2 and 1. So in this circumstance, we would reject C equals 1 just because it's not within the given domain. It's actually one of the endpoints itself. -1, though, does fit between -2 and 1, and that would be our only valid answer, right? So in a question like this, you would have to be worried about multiple choice questions, because certainly if this was a multiple choice question, you can guarantee that one of the choices would be plus or minus 1, and students would definitely pick it. So I hope that this is very helpful and sufficient for you to work on your Delta questions. Of course, on Delta, you can also click Show Solution, and it'll bring you through the work just as I did. All right, I'm so sorry for being absent again today. It's been about a week now. My daughter is sick, and hopefully very soon she will be better. I will be back to school at Calhoun tomorrow. If my husband needs to take over, he will. Thank you, and I hope you guys have a great day.